Okay, video part 2. I've been having some trouble with the videos today. So this is about sampling. So a random sample is a sample where every member of the population has the same probability of being selected. This is like the ideal thing to do. So it says if a survey was done in afternoon activities about what the tuck shop should sell, that definitely would not be random because only little kids are out at afternoon activities. So that would be really bad because the year 11s and 12s wouldn't be included. Okay, a systematic sample is usually a very good sample, almost as good as a random sample, and this is when every kth member of the population is chosen. So this says, consider a single file line of the whole school coming out of the cathedral and every 12th person being stopped to ask about tuck shop choices. Okay, that would be a much better sample than the one that's at Wednesday afternoon activities. They do this often in airports, where they just count, and then every certain number of people they pull over to do, a screening of them. Okay, a stratified sample is the one that we are going to talk about down here, and I've already written it out down here because I tried to do a video earlier. It's the one that I think they focus on in your syllabus. So it's where each proportion, where the proportion of each subgroup has the same sample. So we might decide how many year 12s are, how many year 11s, how many year 10s, so forth, and pick out a proportion of each of those girls to ask them about tuck shop choices. Now, a self-selected sample is a really bad one. That's like when you text to vote somebody off a reality TV show. It's never representative of the population. So in this example down here, which I've already done, it says a survey is to be conducted of middle school that has a distribution detailed in this table. It's believed that students differ in year levels and may respond differently. So the sample should reflect the subgroups in that population. So it should be stratified. So that's the word you're looking for. Reflects the population. So the first thing you need to find is the N. So it's 100, because they're taking 100 students, and how many from each year group should be selected. The next thing you need to do is add up all the kids in those year groups. So this is the total of all the kids in each year group. And then I set up a little proportion. So I do, of year 7, 174 students over the total, and I multiply by 100, the N students, and I get 39.2. So I say in year 7, there should be 39 students. And likewise, the same thing happens for year 8 and year 9. And I can't put decimal number of students, so I round them off, and I just make sure at the end that when I add them all up, I get my 100 students. Okay, there's another page here that talks about the variability of samples. And this is really for the next section of the book. But it talks about, doing a simulation. And they've done a simulation here where they've done some samples. And they said, for example, suppose we draw a random sample of size 50 from a normal distribution with a mean of 10 and a standard deviation of 7. And you can use these computer-generated simulations, and all these different things come up each time I do it. So even though you do samples and you're really careful about being very random, there is a variation, a natural variation, in random samples and what they can tell us about the population. And that's what we'll start studying in 13.3. Okay, I think in 13.2, you can do 1 to 17. A lot of these are just questions like, what's the sample size and what's the population size kind of thing. So they're very quick. It'd be good for you to do all those. Don't worry about the tech active ones because we won't be doing any of those simulations.